Welcome to this second tutorial on Flexcom's user interface. My name is Angus Connolly and I'm the product manager for our Flexcom software. In this tutorial I'm going to focus more on the file view. In the previous tutorial you would have seen how to use the keyword editor to define your model in Flexcom, or alternatively the table editor, which can achieve exactly the same effect just in a different format. I also briefly introduced you to the model view, which shows you a preview of the structure before you've actually done your simulation. So right now I'd like to actually focus more on this file view component, which is on the left of your screen here. So the first thing to notice is that this is exactly like Windows Explorer. So when you all Flexcom simulations must be done as part of a project workspace. So you define a project at the start, be it a new workspace that you have yourself, so I can define a new project, and then you add files to the project. Right now I've already got a workspace set up, so I won't bore you with those details. Alternatively, you can look at the help menu, and there are a range of sample projects available to you. So different types of riser systems, common applications for Flexcom in offshore oil and gas. I'm looking at a very simple project, which is number K1, which is just a steep S riser system. Very simple model, just one riser, not many elements in it, and we'll use this for illustrative purposes. So in the file view, there are just the selection buttons here. All Flexcom inputs are defined in what are known as keyword files, and these have the extension of KEYX or KEYXM for metric, or I for imperial. And we can cover unit systems in a subsequent tutorial. For now, let's assume we're working totally in metric. So these are the input files. I've got a static analysis, and then I've got two dynamic simulations. I have another static analysis there, which I don't really need. I can just delete that one. So if I want to run the static analysis, I made some changes in the previous slideshow. Now I'll just say I do not want to save those changes because I just may have broken some inputs. So I'll relaunch that static file, and now I want to run the analysis. So there are a number of ways you can run. You can press this run button on top here. You can just hit the F5 key once you're in the keyword file itself, but I prefer to run from the file menu. So let's just run this static analysis and let's see how that goes. So underneath you can see the analysis status window. This lets you see the progress of the simulation, which is currently being undertaken. In this case it's a static analysis, so it runs very quickly. So it does some simulation and then some post-processing. You can see this little green tick icon. That means that the simulation completed successfully, and hopefully you can see this on your screens as well, but there's a little green tick icon there as well beside the file name in the file view. This means it's completed successfully. If it didn't complete successfully, it would have a warning symbol, like it failed, or some alternative symbol. You might have noticed that while it was running, it had this hourglass, which means it's in progress. If it runs with some warnings, it'll give you a tick mark with just in an orange background. You probably didn't notice, but the model view has updated now to being a full finite element solution rather than just a preview. So down at the bottom here it says database as opposed to keyword, which it was previously. So let me just go down. Let me change one of the inputs maybe for. I'll just make the ocean say 1 meter deeper. So now you'll see this has gone back to keyword. This is a preview. So once you change some inputs in the input deck, the model view reverts back to a preview or a keyword representation of the data rather than a fully completed static finite element solution, in which case the solution will say database down here. If you actually come back up to the analysis status of the file view, you'll see now that it has a little red asterisk mark. What this means is that the analysis has succeeded, but it's now changed. So because I've changed some inputs, I really should rerun the simulation again, because otherwise my results for this model may be out of date. So I'm just going to do that again. But in this case I'll just show you some other options. Rather than just running that static file on its own, I might just run a branch run, which would be, I can start, let me just take you to the run menu. So I can run the analysis on its own, or I can run I want to run a branch analysis. What does a branch mean? A branch means that Flexcom will run this simulation and any dependent simulations. So in the case of my model here, I've got a static analysis, and I've also got two dynamic simulations, one of which is the regular wave and one of which is the Pearson-Moskowitz random spectrum, both of which restart from the static analysis. So if I open up the keyword file for this regular wave simulation, you can see that it's got a restart keyword and it points to the static simulation as a preceding solution. So I could actually right click on the static analysis, and instead of just running it on its own, let's run all three together. So in this case, Flexcom runs the static solution first and then any dependence simulations afterwards. So we can see this in the analysis status view. This one is in progress, it's got the hourglass marker on it. These ones are in the queue, so they're ready to be run, but they're not in progress yet. So it's just kicked off both of those now. Let's make this a little bit bigger for you so you can see, hopefully. So these are actually running, so I can actually, while it's running, I could sort of pause it. That one's a very short analysis, so the pause command, yeah, it's just kicked in as it went directly to post-processing, but it was really quick, so I'll just resume that one. And you can see that the regular wave obviously runs very quickly because it's a very short simulation. The random C will take quite a bit of time, so you can see that the simulation time is about just over 100 seconds, and Flexcom is telling me that this has got about 46 minutes left to run. I can pause that analysis if I wanted to, so if I prefer to try something else in the meantime, I can just pause that and then I can kick off another analysis. Let me just make this analysis status view a bit bigger so you can see. This example is very simple, very trivial, but if I have a lot of different files and I didn't really want to wait for this one to run, I could pause it and then I could kick off a new job while I'm waiting, while the other one is on hold, and then I can pick it up when it's finished. I can also, if this analysis status view gets quite cluttered very quickly because, you know, once the simulation is finished, it just persists in the view. So any ones that are finished and you want to clear them, you can just go delete inactive jobs, and that just leaves only the ones that are currently in progress. And I'm just going to resume that one as well. In the file view as well, you can set priority for jobs. So if there's one simulation which you think is more critical than the others in the queue, you can set that as being a high priority. That means while analyses are being queued up, you can say which ones are more important, and that determines what the run sequence is. Otherwise, the run sequence is determined by the hierarchy between the files. So it runs static first, and then any dependent simulations like current or wave simulations afterwards. You can also stop all analysis if you want to, you know, free up resources or reboot your machine or whatever. You can stop everything. So that's quite a bit covered there. In the file view, I covered the branch analysis. I can also run what's called a Rouge Analysis, which is basically the reverse of a run branch. So I can click on a dynamic simulation and I can run Rouge, which means it runs this simulation but also the preceding ones. So any ones that is dependent on it will make sure that you pick up those changes in your simulation. For example, if I change some model properties, you know, some structural properties of the model, I could rerun the regular wave but also make sure that I've run the model again by running a Rouge analysis. I think that's fairly straightforward. So once these simulations have completed, in order to reduce clutter in this file view, I have a number of options up here. This is keyword files, which means it only shows me input files. This next one shows me Flexcom files, so you can see already there's quite a number of inputs in this, a number of files in this project workspace, as well as the inputs. So I'll just explain to you what each of those are. FC project is just the Flexcom project. That's just a wrapper for all of the other files. This DBM is a database. It's a database which stores results. What we can do, you can click on that and it'll bring up the model view as a separate application. It's called a database viewer. So it's exactly the same as the model view, it just uses it as a standalone application, which can be quite handy. So you can take it outside of Flexcom and examine the model in detail away from Flexcom environment itself. That's called a DBM file. The keyword files we've already met. The output file, the .out, this is a very simple text-based output file. So it basically is an echo of all of the data you've put in. So if you want to check any properties, let me just sort of check some element lengths here. I can search for the word length, and I can check out the element properties. So the element lengths are here. So it's really for QA purposes that you can actually double check all your inputs in a text-based output file and show you exactly. It provides more insight into what's actually happening in the solution, and if a model doesn't converge for any reason, then it will give you some more insights as to why that may have happened. But we can cover that in subsequent tutorials. The next thing I would like to show you is these plot files in PLT. These are results files in plot format. In a subsequent tutorial I'll go into this plotting module in detail, but for now it's just sufficient to know that these MPLT plot files represent Flexcom plot files, and you can open by just double clicking. You can open any file by just double clicking in the file view. That is pretty much it. This is the summary output file, which we'll cover in summary post-processing later on. This one is empty because I didn't actually request any, and these are tab is just a kind of a tabular representation of the plot files, and you can also send these plot files to Excel as well. I won't cover that. It's just, you can figure those out for yourself, but there's a range of files there. If your input deck gets quite cluttered in Flexcom, you know, if you want to just focus on one particular file, a very handy option is to right click on the file and go close all but this. So you just right click on the title, close all but this, and you're back to just that single file on screen. So there is all the file types that you need to know about. A very handy option in this file view as well is the directory cleanup. So let's say I'm doing some modifications to my model, and I wasn't entirely happy with everything. I can just clean the directory, and I can take out everything, or I can just take out selected files. I'll just clean the whole directory there and get rid of a lot of files. And you can see that it just deletes everything bar important files like your inputs, REO inputs, Excel files that you may have kept as well. That, I think, concludes the tutorial on the file view. So I'll leave it at that for this tutorial, and in the next tutorial I will actually show you some more insights about the additional options on the top menu which we haven't already covered, such as analysis preview options. But for now I think that concludes the tutorial on the file view and the analysis status window.